Okay, let's continue from the previous video. Previous video, we're talking about line integral in general and how to deal with it. And we also know how to construct a path, a straight line path. So today, let's look at an example. Okay, so let's do this one. So we're gonna do a line integral, and this is a form that we talked about last time, right? Something dx, something dy, and then we have a path that consists of two straight lines, right? So instead of reading out loud what it is, let me draw a picture, right? So this path consists of two parts. We have the straight line from 1, 1 to 2, 3. So 1, 1 go like, so this is 1x, 1y. This is a point, 1, 1. And then you go to 2, 3. So 2 on the x and 3 on the y. Okay, so we get this point. All right. So first we walk up there. Dum dum. Right, so that's 1, 1, 2, 2, 3. But oh, you're not done. No, no, you're not done because the second part is from 2, 3 to 3, 0. So 3, 0 is 1, 2, 3 on the x and 0 on the y. So this is 0.30. And then you go all the way down. Like this. All right. So this whole thing, this whole upside down V is C. All right. And we basically ask for this C, what is the integration of 2xy dx and x squared dy? All right. So what do we do? The way we do it is when you see a straight line that look a path that look like a broken line together like this, you should think of this as like two part, C1 and C2. All right, and instead of integrating over C or something, you're like, no, no, I'm not integrating over C because it's too hard. You're gonna break down into two sub problems. Gonna integrate over C1 and integrate over C2. All right, so this problem is actually just two problems hiding. All right, so what are we doing in these two problems? Let's start with C1. All right, so C1, what it is a straight line that go from 1, 1 to 2, 3, right? So let me copy this and put it down here and say that like we don't care about this anymore, okay? All right, we're just gonna go from 1, 1 to 2, 3, and that's it. We don't do anything else. Okay, we're just gonna do that. And once we realize we're gonna do that, then we can parameterize C1, right? Parameterization of C1 is just a starting point, which is 1, 1, plus the n minus the start. So 2, 3, minus 1, 1, times t, where t between 0 and 1. All right, so 1, 1, plus 2, 3 minus 1. 2 minus 1 is 1. 3 minus 1 is 2. So we get 1, 2, t. So we multiply and then add them together. So we get 1 plus t, and then 2 plus 1 plus 2t, sorry. And that is our x. and that is our y. Okay, and now we're ready to integrate over C1, right? So what's the function again? Is 2xy dx plus x squared dy. Okay, so now we're gonna do like we did in the last clip, that we transform everything into t, starting with the integration cycle from 0 to 1, and then we start substituting x by 1 plus t and y by 1 plus 2t. So let's do it. 2x, x is 1 plus t, y is 1 plus 2t, and then dx, remember, x prime will be equal to 1 and y prime will be equal to 2, simply because 1 is gone, t become 1, and 1 is gone, t become 1. So we have 2 and 1. Okay, so that x prime would be 1 because that's dx. Next up is x squared, so 1 plus t square, right? Because that's x squared, and dy would be y prime. So that would be 2. And dt at the end. Okay, so this is a lot, very annoying, but we have to do it anyway, right? So we have two parentheses, we have two terms. We're gonna have to expand them to integrate, right? The left one we have to do, we have to FOIL out, meaning we have to do front and front, front and back, back and front, and back and back. So this is front and front, this is front and back, and then we have two more, back and front and back and back, right? I'm gonna write down the result here. If you do front and front, we have 1. If you do front and back, you have 2t. Back and front, you get t. And then back and back, you get 2t squared, right? And remember, you have to multiply everything by 2 too. Okay. The later one is different strategy, is something plus something square. So you get front square plus 2 front back plus back square. So that would be 1 plus 2t plus t squared. And remember, this is just this part. This is just this part, right? So everything has to multiply by 2. So let me write out the result when you multiply by 2. So you get 2 plus 4t plus 2t plus 4t squared, right? Getting from multiply by 2 everything. Okay, and the later part is you multiply by 2 to all of this. So you get 2 plus 4t plus 2t squared, everything dt, and then we have a plus sign at the end. Okay, I'll do one more step and leave it as like you can compute like in between by yourself, and I'll just tell you the answer. So this one, 2 plus 2 is 4, right? And the next one, the t term, the linear term, you get 4 plus 2 plus 4, that would be 10. And the last one will be the square term, you get 6t squared dt. All right, after this is just regular integration. 4 become 4t, 10t become 5t squared, and 6t squared become 2, 3 cubed, right? I'm gonna leave this as an exercise, and then you can see that the result is 11. Okay, so with that, let's conclude what happened here, right? When you start with C1, you find parameterization of C1 that look like this. Use a formula that you have like A, B minus A, T. You get parameterization of the line. Then you would combine them and do integration. All right, let's do the same thing for the C2. All right, C2 look like this, which give us C2t will be the starting point plus n minus start t, and then t from 0 to 1. All right, so get 2, 3 plus 1 minus 3t, right? Because 3 minus 2 is 1, and 0 minus 3 is minus 3. All right, all in all, you get 2 plus t, and then 3 minus 3t. T between 0 to 1, and we can repeat the process saying that integration of c2 to xy dx plus x squared dy would be the same as, okay, let's do it one by one. The integration type becomes 0 to 1 because that's what we do. You look at the bound for t and then you integrate. Then we have 2 plus t, 3 minus 3t. And then if this is x, this is y, x prime you know that is 1, and y prime is minus 3. So we have 1 here because that's the x. The next one is x plus x squared, so we have 2 plus t squared. And then you have minus 3 here, dt. All right, just gonna do one more line and leave everything else as an exercise, just like before. But let me FOIL this out again for you. Right? So if you do front to front, front to back, back to front, and back to back, you get 6, right? That's front to back, you get minus 6t. Back to front, you get 3t. And then back to back, you get minus 3t squared. This one, you would get 4 plus 4t plus t squared. That's what you get from front square plus 2 times front times back square. All right, everything multiplied by minus 3 on the back, and everything multiplied by by plus 2 on the front. I mean, this go everything, right? So you get 12 minus 12t plus 6t minus 6t squared. All right, that's the first one. And then you get minus 12. You multiply 3 to this one, right? So you get minus 12 minus 12t minus 3t squared dt. All right, so after this is not too bad anymore because you just combine term 12 and 12, right? That's becomes 0. You combine the t term, and then you combine the t squared term. After that, you integrate, and the result should be minus 12. All right, so now we did both sub-problem, right? We did C1, the answer is 11. We did C2, the answer is 12. So C in total, so integration over C to xy dx plus x squared dy would be the same as you do the same thing for C1, and then you do the same thing for C2. Right, as simple as that, right? In terms of picture, if you do the whole thing, right, it's the same thing as you do the first part, and then you do the second part, right? But we computed before that the first part is 11, the second part is minus 12. So the final answer to this problem is minus 1. Okay, so let's continue. So the next part we're going to talk about the notation we usually see when we do line integral, right? So we're not going to see, we're going to see this sometime, like something dx, something dy, but actually what we're going to see a lot is this notation f dot dr. Right, so what you usually see is you're going to see a vector function which you look like f xy. Sometimes we call this vector field. right? I encourage you to go look up what vector field kind of look like actually. Um, but to starter, it's like you have a field and each point you have a vector, and that's what's happening. In this case, you have a point inside and then you have the vector on the outside, right? But what you want to know is you want to see that like this is a two function combined, and they say um, we can compute, right? So this is a new notation. This is something called integration of f dot dr, right? F dot dr, whatever it means, right? This is what they can ask given a vector field and given a path. They can ask you what is f dot dr, right? So this is something that make it look scary of what it is, right? But actually, it's just this thing. It's just integration of p dx q dy, which you have seen before. This is what you have seen before. It's just the first function dx, second function dy. No problem, right? So um, so whenever somebody asks you to do this, it's just a fancy way to see this, and it's turned out to be the problem that we did before. So let's do that. Okay. All right. So um, a question can be go like this, right? Given a vector field that look like this, a vector field or the f will always look like this. You have two function, the first part and the second part, and they ask you to do integration of f dot dr when you give c like this, right? So what we do is you just translate this problem to p dx q dy. We will just integration over c still, and then you do the first part dx. What is the first part? First part is xy dx, and then you have the second part, which is x plus y dy, like this. Very simple, right? And once you have this, you can translate it to t, just like before. So for t, you use this fact, right? So let me copy it down, box it in green, and then we say that, oh, this is integration from 0 to 2. X times y is just, this is x, this is y, right? So x is t squared and y is 3t plus 1. All right, and with that, dx will be 2t and dy will be 3. All right, for those of you who didn't see where it came from, it's just this part that like you have t squared become 2t, and then you have y 3t plus 1 become 3. All right, so dx will be 2t, and then x plus y will be 2t plus 3, and then dy will be times 3 dt. All right, now we simplify by distributing around. The first term will be 3t3. Um, 3, 4, right? Okay. Hold on. Is both of these distribute in, right? Right. So the first term you get 6t4, and the second term you get 2t3, right? And this part you distribute this into um okay. So hold on. X plus Y is gone wrong, right? X plus Y should add these two, not add these two, so confused. X plus Y should be t squared plus 3t plus 1. So sorry about that. So we get 3t2 plus 9t plus 3 dt. All right, so 0 to 2. You integrate now, right? You get 6 over 5 t to the 5 plus 2 over 4 t to the 4 plus 3 over 3 t to the 3 plus 9 over 2 t squared plus 3t t from 0 to 2. All right, you plug in 0, everything gone, you plug in 2. I will let you figure out the rest. I don't know the answer, but that's not the important part. Important part is how you translate this to this, and then you distribute the rest. Okay, so that is the DR part. All right, so from now on, we'll use this notation a lot together, sometime with this notation, the something dx, something dy, and that would be it for this clip. So next clip, we're gonna learn more about line integral, but we're gonna learn in terms of the theory behind. What do you do if you don't want to compute for so long? What can you do with the theory side, right? But for now, thank you for watching. I'll see you again next clip.